Welcome to the Anti-Pattern Podcast, your ticket to the revolution in digital thread technologies. Please welcome, live from Mannheim, Germany, your hosts, Christian Muccio and Michael Fenning.
Hello, 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 and welcome again to the Anti-Pattern Podcast, live, not really live, but close to live from Mannheim downtown. This is our 20th episode. So this podcast is not a teenager anymore. We turned 20 now. Together with me again, Christian. And today will be the first episode on the topic of AI. Finally, we have been talking about this quite some time already, right? But today we are going to start with a little overview. What is it that we are thinking? What is it that EP is thinking in terms of artificial intelligence? This is the main theme for today. And to give it a little more, or to make it a little bit more specific, it's about industrial AI, right? It's not just AI in general, right? There is a lot of stuff going on, and it feels like we're in the middle of a big bubble again, right? Like 99 or 2000, right? But today will be only about industrial AI and what are the current pains? What is actually stopping us from really introducing something like a whole bunch of AI agents to help engineers work? And this is going to be today's topic.
Right. Yeah, and the question is, as you already stated, who can use it already now,
right?
And what is holding us up to use it for other disciplines? And we, as a software developing company, as a tool vendor, we are using AI right now. And
already, yes.
Of course, software engineering is maybe one of the most obvious cases where AI really works well. So we see it when Thomas is writing his his test cases with AI.
Right.
I use it very much for vibe coding. I more give the software or give the LLM the architecture that I want,
right,
and let it vibe code much of the TypeScript code
for the front end.
For the front end, right, which works very well, and it's amazing to see how the AIs, so Anthropic and Gemini and OpenAI, how they evolved in these, 10 months that we are existing?
Right.
How it evolved in that time, in that time frame. That's amazing.
I actually remember, I guess it was in the summer, and you sounded like a cyclist who was, taking some not allowed doping medicine, whatever, because you said in the morning, today are going to be fast because there was an update on OpenAI. I remember this quite well, right? You really felt it.
Yeah. That was a very interesting week when ChatGPT 5 was released, and all the influencers who tested it before complained about it. And I used it for my first prompt, and it was amazing. So for our case, it was a real advancement.
Yeah, for sure.
Yeah, and the question is, apart from software engineering, what can we do now, or what is holding us up to use it? And of course, there are already implementations and usages in hardware engineering,
right,
or other enterprise applications, but software engineering is dominating from my point of view.
Yep.
Absolutely.
Definitely. And when you talk about enterprise applications, there's this one guy, Ed Honor, that both of us are following.
Yeah, on Instagram.
On Instagram, I do see his reels like once or twice a week. And he, a couple of weeks ago, I think, or maybe 2 months ago, he was stating that what would AI mean for ERP systems, right? So SAP, Oracle, PeopleSoft, right, in the, decades ago, because ERP systems usually need to be customized, need to be configured. There's a lot of consulting involved, so it's not just that you buy the software. The same is true for all of the PLM systems. Same is true there. It's even more, I would say, in terms of how much it needs to be configured, right? And the question is, can we then configure it by AI, right? Do we actually need so many consultants to configure the system, or can we use less consultants that use AI agents to do this, right? And that was a really interesting question that he raised here, right? And we have been talking about this before, right? With
Yeah.
the research project that we basically handed in.
Yeah, exactly. Yeah. Yeah, this is one reason why we applied for more than one research project about AI and the usage of AI for different industries, but also in the context of our solution, how our solution could benefit from it or give a benefit to the users. And yeah, this idea is not new. And I think this is also the fear of many consultants and software engineers.
Yeah.
What will happen with my job if AI gets better and better and better?
Right.
And we will talk about the actual problems of AI in some minutes. But as I said, it gets better and better. And the hope that we have as a software vendor, but I think everybody in this industry is that it does not cost jobs, but it makes implementation of any enterprise application like ERP or PLM or a digital thread system, it makes it just cheaper, and you can
better,
and you can serve more customers with the same workforce,
and also facilitate the fact that things need to change quickly today. Not like 25 years or 30 years ago, where you were able to statically implement a system and then run it for 10 years without any changes, right? That's not the case anymore. You have to be agile, right? And you have to change your settings. And that includes, of course, the enterprise applications that you're running.
Yeah, and I think this scenario is not far away. So the best example is what I did in the morning. We are preparing the demo for the TDSE next week, a tool vendor project, and we need some sample data. And what I did in the morning was to generate a JSON of a specification, of a requirement specification. And I just generated the specification itself, and in one REST call, so to say, a hierarchy of 3 requirements. And with this JSON, I told the LLM, take this as an example and generate me a specification of 200 requirements for a Mars rover, because that's the example we are using.
Right. And that's the one thing. Generating example data is the one thing. The other thing is, of course, and you did this as well, please propose a data model, right? Type definition for me, right? For requirement structures, well, whatever we have been talking about, right? And one side remark, and that's more a joke. One comment that is under one of the add-on or reels is, who is this JSON and why do I keep hearing about it?
Yeah. So quite an old one, but yeah.
That's a good one.
Yeah, exactly. And that's amazing to see how the LLMs can work with this couple of information, a little bit of information, and you're getting great results. And as you said, also for the data model itself. And this is definitely also our plan to describe our platform in a way that a LLM can understand it. And I think in the beginning of next year, we will try this out to say, hey, I want a new package, a new application, a new domain-specific application. Please write me some lines of business logic here and there, and create the data model, and then get a first draft of a domain-specific application. And so I'm pretty confident that this will work.
Yeah, definitely. And I mean, this is the one thing, configuring an enterprise application like ours by prompting, right? This is the one thing that we definitely are working on and that we are discussing. I said this is going to be the first episode on AI. We will have a second one definitely later this year, because we will have a AI research day, end of November 27, where we invited a couple of German researchers talking about industrial AI and what does it mean, what do we need to do, what do we need to fix. And this is going to be the topic for the rest of this episode. What are the pains, right? What are the actual pains that we need to look at, right? How many did we find today?
Yeah, we thought about 5 major criteria, and another thing we should talk about, but it comes right away in the next points. Yeah, so just start over.
Yeah. So those 5 things. The first one that we came up with is, of course, and that's not just specific to industrial AI, right? It's AI in general. Is hallucinations. Right? So and in terms of severity, right? So how bad is it if the AI is hallucinating? If my text is not correct, if the picture looks crappy, right? If that stuff didn't work out, it's bad, but it's not a nightmare. If your bill of material is not accurate and you cannot produce, therefore, and create a lot of cost in your production, then it's a nightmare, right? So the severity is way bigger in industrial AI. So if things go wrong, right, when stuff is hallucinating, then we will have a huge problem. So in other words, it must be way more accurate for the use cases that we are talking about.
Yeah, and AI should have a switch to definitely not hallucinate or reason again up across the answer, or it should see for itself that it was hallucinating.
Right. And one option to do this that we have been discussing, and there's potentially way more options, right, is why not have the AI work together with existing tools? For example, simulation models, right? Because simulation models will add constraints, right? If the simulation model will say you're completely out of bound, right? Then your answer cannot make any sense. So you need to stay within the constraints of the simulation model. For example, for some use cases, this will help. Other tools are needed for other, use cases in that context. I guess you can summarize and say AI is not so good at causation, right? Understanding causal. What is it? That things are related causally, right, and not correlating, right? Because AI comes from data analytics and statistics, and so you would expect correlation is the big thing, right?
Yeah.
Causation to have actually the AI understand that something is caused by something else, right, is a bigger deal.
Yeah. And I think what will help there is if you let more than one AI agent work on the problem,
Right.
and work this out. Because, the one agent might be coming up with a solution and the other agent will test it.
Right.
Yeah,
Right.
and question it.
Right.
Yeah. Yeah, the second topic is IP protection. IP protection, especially in Germany, is a big deal. Everybody is afraid losing his IP. And the question is it really a thing? If you look in the architecture, how these implementations of AI work. So I think one of the main problems is that many people are using ChatGPT. And ChatGPT seems to learn because it gives you answers based on your prior questions. But the thing is, it was not the LLM itself which reminds on, I learned this and that, and this is why I give a different answer to this user. It is that your previous questions are in the context of the request.
Right.
This is where it seems like the LLM is learning. But memorizing, exactly. But the reality is that these are two separate parts of the architecture. The one is the knowledge itself, to reason something, to figure something out. And the other thing is to memorize questions and answers.
So the language model and the reasoning is the one thing, or is this kind of your? I'm not sure. I'm not an MD and I'm not a psychiatrist, but this is the prefrontal cortex, right? That's the thinking, right? And the memorizing, right, where you save your information, is something completely different, right? So don't try to, or do not make the mistake to compare AI directly with human brains. It doesn't make sense. It's different. Right. And I mentioned reasoning, right? So there was this famous, it got famous over the last month, Apple research paper, right? Where they said, it's actually the AI is just memorizing. It's not really reasoning, right? And there is a lot of discussion around this topic. How good are those AIs in the moment in terms of reasoning, understanding, thinking through, and showing their line of thought. Right? So how good are they? And there is one, I would call it a thought experiment, right? Think about you are Galileo, you are Einstein, right? And you have a really great breakthrough innovation, breakthrough theory, right? And you give the AI your theory, explain it to it, and then the question would be: is the AI understanding and actually verifying that what you're talking about makes a whole lot of sense, right? It's really, would it recognize this breakthrough, right? Or would it say, oh, everything I learned up until now, all the papers that have been written in this topic, right? Everything, that is common knowledge is contradicting your theory. So your theory must be wrong, right? So is it actually reasoning because it would, actually understand this new breakthrough, right? Or is it just memorizing all of the stuff that it has been learning before? So this is a great question, right? The question is how far did we come in the actual reasoning part here, right? And that, of course, for our use cases plays a big role. Right?
Yeah.
Right, because it's more rational. It's not just memorizing, bill of material, bill of process, and all the other kind of information here, right? It's also, does it actually make sense, right?
Yeah. And this is very often a domain-specific question.
Right.
And the question also is an LLM generally trained on this, or did you fine-tune it on your special domain?
Right, and we come to that question in a moment. But you also were talking about where the knowledge is, so to say, saved, right?
Yeah, right. And this is our fourth point on the list, which is about the availability of your knowledge on which the LLM will work on or can work on.
Right.
And this automatically means your knowledge or your knowledge graph has to be accessible for the LLM from outside, from inside, wherever. It needs to be accessible. This is the prerequisite one. The other one, which is not really a prerequisite, but will be absolutely helpful, is when your data is there or is accessible in a machine-readable way.
Semantics. Yeah.
When you have a semantic-rich answer to the question of your LLM,
right.
and we tried that also out last week.
Right.
We wrote an MCP server for the first time, connecting our knowledge graph, our digital thread system, to an LLM, and through this, and it was amazing to see what happened. So through this MCP server, you basically give the LLM a specification or a manual how to use your API. And it's a couple of lines of code. It's not very much, some 100 lines of code. Yeah. It's not more. And with this MCP server, we were able to ask, again on the example of the Mars rover, hey, dear LLM, have a look in the digital thread system of a paired Mars rover, and tell me how many, how many bomb positions are on the first level of this part hierarchy. And what the MCP, or what the LLM was doing then, was to ask the MCP, what can you offer me? Okay, this and that and that. Okay, there is a type definition. Let me look up the type definitions. Oh, there are parts. Okay, this is what the user meant. Let's ask for the parts on another endpoint, which was also offered by the MCP server. And then was searching for the Mars rover. And the amazing thing was that it understood the answer, that there is obviously a hierarchy, that there are relationships, and it found the relationship EBOM and looked up everything under this relationship. Yep. And could name us the four, it was 4 parts by its name and its part number. What are the 4 first level bomb positions.
Yep. And what I found amazing here, that it's actually using our type definitions, right, from our meta, and then from the domain-specific models that we are creating, right? And the other thing, you mentioned knowledge graph. This is our home turf, right? This is what we have been working on for the last 9 months, basically, right?
Yep.
And what I always find so interesting is the very naive understanding of many people that there will be an AI agent that you just have to give your logging information to certain systems, and it will look up in many different tools, information, and then give you the answer. This may work for a couple of them, or one of them, or it will work to some extent, but the interrelationship between product data, because product data specifically has a huge problem, that is, it's spread over so many different tools, right? So especially in our domain, where it's about industrial product data, there are no interrelations captured anywhere usually, right? You have one SAP system knowing about bill of material, you have a PDM system knowing about bill of material information, you have a CAD system, you have whatever it's so spread over your architecture, and therefore you definitely need a knowledge graph to bring to the table the understanding of how things are related.
Yeah,
right?
yeah, yeah.
Then the AI actually makes sense.
Yeah, and we have the second example where real semantics did play a role. So it was the example of an address type, and we gave the data model of the address type and all the properties. We gave them schema.org semantics.
Yep.
And with this information, the LLM could generate an RDF of certain addresses which were in the knowledge graph. Right. That was also very interesting to see that the LLM understood very well what it was, and across product data, it will be an enormous, how to say, semantic advancement. Yeah. The question I ask myself is, who is defining the ontologies for this? Yeah. What is a BOM? What is a simulation? What is a test? How does a test stand against requirements?
And there will never be a perfect world here, right? But having ontology, you called it ontology namespaces, right? This is what we called it. So this makes a whole lot of sense to have it. The question is, where is the information coming from? More than one organization, more than one resource in the internet, basically, right? It gives us that additional information. But ontologies play, of course, a very, very big role. Coming to the last point, and this sounds a little uninteresting, to be honest, but not really interesting, but costs, right? So who shares what kind of costs if you want to introduce AI agents in the industry, right? So why do we bring that up? It's also a naive understanding of many people that there will be big industrial companies training from scratch their own models. It's not going to happen, right? It's too expensive, right? You have to have all of the GPUs, right? And all of that, example data, and the team that is actually doing it, right? So there will not be a lot of companies doing the actual training, right? The question is, what strategy can you follow? What resources can you share? Right? As we said, your proprietary information should stay private, should stay with you, right? So you potentially will have your own knowledge graph, because this is where stuff is memorized, right? But sharing resources in terms of reasoning in language models and so on, we use DeepL to translate stuff, right? With our tool, right? I guess we were already talking about this, right? So no problem sharing that resource, right? So this can be multi-tenant, whereas your knowledge graph should be single tenant or on-prem, right? To just keep your stuff with you, right? So this is also kind of an answer to the question, how can I save money and how do I make sure that it's not getting too expensive? And the other thing is, what strategy do you actually use, right? Do you use a standard model and just use the standard model, just find the best one out there and then use it, right? That can change over time because those models are evolving very quickly. Or do you actually need to follow a fine-tuning approach, right? Where you take something and then fine-tune it for your needs? Question mark. I hear people talking about this being also expensive, right? Other people saying, oh, it's not that expensive. So this is actually the question. Do you actually do fine-tuning, right? And what other kind of approaches are we following here? One spoiler, graph rag. obviously something we need to talk about because we have the graph, right? And our graph could be the graph RAG, right? The retrieval augmented generation for, that stuff. But we do not have a final answer to this yet, right? So this is what we are working on. Right. With that being said, so this is just the pains, not yet the gains, right? It's not yet, our solution to what does actually industrial AI mean. We are working on it, and we'll give you an update beginning of December after our AI Research Day, which is happening on November 27. And up until now, I hope this was worthwhile listening in, and talk to you soon then. Bye-bye.
Goodbye.